Hi everybody. In this video I would like to explain the concept of inductance of a three-phase overhead lines. In order to calculate the inductance of a three-phase overhead lines, I am considering the three conductors A, B, C of a three-phase line carrying a currents of this is the conductor A, it is carrying a current of IA, and this is the conductor B, it is carrying a current of IB, and this is the conductor C, it is carrying a current of IC. These three conductors are spacing with a distance of D1 between the B and C, and the distance of D2 between A and C. The spacing between the A and B, it is of D3. These three are the conductors. This is one of the conductor A, this is the conductor B, conductor C. These all are the transmission lines, overhead lines. That means the system is the three-phase overhead lines. Assume that the loads are balanced. Whenever the loads are balanced, here is a condition that IA, IB and IC is equal to 0. Then, in order to calculate the inductance of a three-phase overhead lines, consider the flux linkages with conductor A. Consider the flux linkages with this particular conductor A. The flux linkages with conductor A due to its own current and also due to the mutual inductance effect of IB and IC. Already you are discussed in the previous videos that in order for the calculation of the inductance, you need to calculate the value of the flux linkages. That is, L is equal to psi by I. You need to calculate the value of psi, that is the flux linkages. These flux linkages are obtained by due to the internal flux and due to the external flux. That means the current passing through the same conductor and it produces the flux linkages, and along with the one due to the mutual inductance effect, that is the current flows through the conductor B and the current flows through the conductor C, that is IB and IC respectively, and this produced fluxes is linked, the conductor A, this conductor A, and this phenomena is called as mutual inductance effect. The flux linkages with conductor A due to its own current, that is mu naught Ia by 2 pi 1 by 4 plus integral r to infinity dx by x. Let it be the expression number 1. Then the flux linkages with conductor A due to the current IB, that is because of the mutual inductance effect, the current IB that is passing through the conductor B and it produces the magnetic field lines, and that is linked to the conductor A, and it produces the flux linkages that is of mu naught IB by 2 pi integral d3 to infinity dx by x. Let it be the expression number 2. And the third one, that is the flux linkages with conductor A due to the current IC, that is the current which is passing through the conductor C and it produces the magnetic field lines. That produced field lines that is linked with the conductor A, that effect is called as a mutual inductance effect. And because of that one, we are producing the flux linkages are nu naught IC by 2 pi integral of d2 to infinity dx by x. Let it be the equation number 3. And the total flux linkages with this conductor A is psi, let it be, the indication is the psi suffix A is equal to the expression number 1 plus 2 plus the expression 3. While solving these 3 expression summation, it will give us the total flux linkages. See here, the total flux linkages with the conductor A is psi A is equal to 1 plus 2 plus third expression. That is, see here, nu naught IA by 2 pi 1 by 4 plus integral r to infinity dx by x plus nu naught IB by 2 pi integral dt through d3 to infinity dx by x plus nu naught IC by 2 pi integral d2 to infinity dx by x. In all these 3 expressions, we are having a common term that is called nu naught by 2 pi. See here, nu naught by 2 pi. In the first expression, nu naught by 2 pi. In the second expression, nu naught by 2 pi. The common term is nu naught by 2 pi. I am common this term to the outside, that is, see here, nu naught by 2 pi. Then the remaining term is 1 by 4, 1 by 4, see here, 1 by 4 plus integral r to infinity dx by x into IA plus IB into integral d3 to infinity dx by x and IC into integral d2 to infinity dx by x. Observe clearly that by the solvation of the applying of the integral and the limits, we are getting this term, this particular term. Once observe this particular solvation, see here, I am writing here, the expression is same. See here, u naught by 2 pi, u naught by 2 pi, this one same. This is the solvation, and by the solving of these expression, you will get this particular one. Okay, see here, u naught by 2 pi 1 by 4 plus integral r to infinity dx by x into IA plus IB integral d3 to infinity dx by x plus IC integral d2 to infinity dx by x. I am applying the integral and the limits here. See, this 1 by 4 into IA plus integral of 1 by x dx, that is log x base e, and applying the integral upper limit minus lower limit. See here, this 1 by x dx, integral 1 by x dx, that is the log e base e into IA, and upper limit is infinity. See here, IA log upper limit is infinity base e minus log lower limit or base e IA plus the same one that is applied to this expression also, that is integral of 1 by x dx, the limits are d3 to infinity, that is log upper limit is infinity base e IB minus log d3 base e IB, and the same we have to be applied for the third one, that is plus log infinity base e IC minus log d2 base e IC. And the further simplification that, see here, in this expression we are having the terms are, see here, IA log infinity base e, and see here IB log infinity base e, and IC log infinity base e. The common term is this one, this log infinity base e, log infinity base e, and log infinity base e. I am writing here that taking the common as log infinity base e and the IA plus IB plus IC, and I am written the remaining terms. See here, this is the IA log R base e minus IB log D3 base e, and the final term, that is IC log D2 base e. Then by rearranging here in this expression, that is we are having the, here in this term we are having the IA, and in this term also we are having the IA. I am taking the common as IA here. Once again I am repeating here, see, in this term I am having the IA, and in this term also I am having the IA, and I am taking the common IA. This IA into the remaining term is 1/4 minus log R base e, and the remaining term is this one, IA plus IB plus IC log infinity base e, and minus IB log D3 base e minus IC log D2 base e. And see here, these two are this is the solution. And finally, for the further simplification of this expression, I am considering here IA plus IB plus IC is equal to 0. That means we are considering the balanced system. We are placing this IA plus IB plus IC is equal to 0 here in this one. This entire term is getting as 0, and the remaining term is psi A is equal to nu naught by 2 pi 1/4 minus log R base e IA minus IB log D3 base e, and IC log D2 base e. Then after, in this one, in the inductance of a 3-phase overhead lines, we are having the two arrangements of these overhead lines. One is the symmetrical spacing, and second one is the unsymmetrical spacing. Symmetrical spacing is nothing but these three conductors or the transmission lines, overhead transmission lines A, B, C are equally spaced. That means D3 is equal to D1 is equal to D2 is equal to D. That means all the spacings are the same length. That particular position is called as a symmetrical spacing. Whenever this behavior is existed in the system, that is the spacing is different, that is for A to B it is D3 and B to C it is D1 and A to C it is D2, that is different spacings, we will call it as a unsymmetrical spacing. Okay, you need to calculate the inductance of these one. See here, for the symmetrical spacing we are having the D1, D2, D3 is equal to D. These all the one having the same distance, that is D, 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 same spacing. We have to be placed that already you are getting the expression for the psi value. See, this particular psi A value. In this one we are having the D3, D2 terms. I am placing all the D1 is equal to D2 is equal to D3 is equal to D. Okay, I am placing all the terms into with the D. See here, psi A is equal to nu naught by 2 pi 1 by 4 minus log R base E IA minus IB log this term. I am placing the D value. I am placing the D value. See, what is the term here? This is the D3. D3, I am placing the D value, and minus IC log this D2. D2 I am placing the D value. Why? Because means all these conductors or the transmission lines are equally spaced. Equally spaced means all the distances are same. That is D value. We are considering here the D value. Okay. This one is further simplified as nu naught by 2 pi 1 by 4 minus log R base E IA minus, see here, in these two terms the common term is log D base E. I am taking the common as log D base E, and the remaining term is IB plus IB. I am taking the common as minus IB plus IC. IB plus IC. Here we are having the final previous one, the consideration IA plus IB plus IC is equal to 0, and that expression I am rearranging here as IB plus IC is equal to minus IA. I am placing this minus IA in this one, and this will becomes IB plus IC is equal to minus IA minus plus IA. See here, the remaining term is nu naught by 2 pi 1 by 4 minus log R base E IA plus IA log D base E. Then finally psi A is equal to, the term is nu naught IA by 2 pi 1 by 4 plus log D by R. Why? Because means this is the minus term, minus log R base E. I am taking the common, that is IA value is taking as common. See here, and we are having that minus log R base E and log D base E. D by R. This is the minus term. That's why we are getting here D by R. Log D by R base E, Weber turn per meter. This is the psi A value. Already you are concluded that inductance value is calculated by the flux linkages by the current value, and we are calculating the inductance for the which one? For the conductor A. For the conductor A, the inductance value is, let it be the LA value, the flux linkages for the A, and the flux current passing through the A. Here the flux linkages already calculated here. This is the value. I am substituting this value in this one, that is nu naught by 2 pi 1 by 4 plus log D by R base E Henry per meter. That means this IA value and this IA value is getting cancelled. This IA value and this IA value is getting cancelled. And I am placing that the absolute permeability value here, that is nu naught is equal to 4 pi into 10 to the power of minus 7 by 2 pi 1 by 4 plus log D by R base E Henry per meter. And for the simplification, that here this pi, see, this pi and this pi is cancelled, and we are having that this 4, this 2, this one is cancelled by 2. We are having the 2. The term is 1 by 4, and this 2 by 4, it is getting as 1 by 2. The 1 by 2 term is 0.4 plus the 2 into log D by R base E Henry per meter. Okay, and this expression for inductance are the same for conductor B and C. While we are applying the same procedure steps for the B conductor B, and you will get the same expression. And we have to be considered for the entire consideration for this conductor C, we are getting the same expression, LB is equal to, okay, and see, and we have to be discussing about the next one, that is inductance of a 3-phase overhead lines. for unsymmetrical spacing. 3-phase overhead lines for unsymmetrical spacing. These 3-phase lines conductors are not equidistant. Already you have discussed it here, discussed it in the previous slide. That is the spacing of these conductors. This is conductor A, conductor B, conductor C. These conductors are unequally spacing. We are not having the equal distance between these three conductors. This is the distance of D1, this is the distance of D2, this is the distance of D3. Okay. For this one, the flux linkages and inductance of each phase are not the same. The flux linkages values and the inductance values of each phase each phase is not the same. One of the important point. And the another important point that a different inductance in each phase result in unequal voltage drops in the 3-phase even if the current in the conductors are balanced. Whenever the current passing through the conductors are the balanced one, because of the difference in the inductance values, there is an unequal voltage drops in that phases, in the 3 phases. Because of these one, the voltage at the receiving end will not be the same for all phases. The voltage at the receiving end will not be the same for all the phases. In order to maintain the voltage drops are equal in all conductors, the produced drawback is the voltage drops in all the phases, all the 3 phases is not equal. Why? Because of the change in the inductance values. Because of the change in the inductance values. In order to maintain that particular voltage drop into the equal, see, we are taking a consideration that interchange the position of the conductor at regular intervals along the line so that each conductor occupies the original position of every other conductor over an equal distance. That means we are interchanging the position of the conductors at regular intervals. We are considering an interval of time for interval of length, for a equidistant length. We are considering the interchanging the position of the conductors. Interchanging the position of the conductors. It means that each conductor occupies the original position of the every other conductors over an equidistant. This particular methodology is called as the transposition. Why? Because we are considering the transposition in order to maintain the voltage drops are equal in all the 3 conductors. And observe clearly this particular diagram. See here, the phase conductors are designed as A, B and C, and the position occupied are number 1, 2 and 3. This is the A, B, C are the phase conductors, and this is the position 1, position 2, position 3. That means this is the phase conductor A. Phase conductor A, it is occupied the position of 1, and after that this phase conductor A, it is occupied the position 2, which is the position of the conductor B in the previous. Okay, and after that, and for equal interval of time, equal interval of length, we have to be considered this particular same conductor, it is occupying the conductor A, occupying the position 3. Like the same fashion, the B, like the same fashion, similarly the C value, C conductor. It means that interchanging the position of the conductor at regular intervals along the length so that each conductor occupies here this one, this one conductor occupies the remaining positions. This position, first one, it occupies the second position, which is the position of the B, and occupies the third position, which is the position of the initially position of the C. Okay, I think you got my point. So each conductor occupies the original position of every other conductor over an equal distance. For equal distance, this will be happened. For your clear understanding, I am collecting and placing here the pictorial representation that see, this is the tower, the phases. See here, this is the phase A, phase B, phase C. See here, the first phase it is occupy the remaining phase positions. See here, this one is changed. I think you clearly understood by the observation of this particular diagram. See, this one, it is interchange, change the position of the next one, and this also it is change the position at a regular interval, and in the next interval it will changes, it will again changes the position. By the consideration of this particular fashion, this fashion we have to be called as a transposition of lines in order for maintaining the voltage drops in all the conductors will be the same by the consideration of this one. See, by the changing of this particular one, by the consideration of this transposition, let us assume that each of the 3 sections is 1 meter in length. Let us further assume balanced condition, that is IA plus IB plus IC is equal to 0. Let the line current be IA is equal to the first position, that is 1 plus J0. The current IB it is changed to I of minus 0.5 minus J 0.866. IC I of minus 0.5 plus J 0.866. Previously we have concluded the expression of the psi A, that is the flux linkages, and I am placing the IA, IB, IC value in this one, in that psi A expression. See here, u0 by 2 pi 1 by 4 minus log R base A I minus I of this IB value is changed I of minus 0.5 minus J 0.866 log D3 base E minus I of minus 0.5 plus J 0.866 log D2 base E. And further simplification that by the expansion of all these terms, see here 1 by 4 I, this particular one is multiplied to this term 1 by 4 I minus I log R base E plus 0.5 minus into minus plus 0.5 I log D3 base E plus J 0.866 log D3 base E plus 0.5 I log D2 base E minus this one J 0.866 log I log D2 base E. Okay. Here also we are getting the I value. See, remember that this value is also having the I, this I into. Okay, and the further simplification here, I am taking the common terms in this one. See here 1 by 4 I minus I log this one, and 0.5 I am taking as the common here, 0.5 I in this one and 0.5 in this one, taking the 0.5 I as common, 1 by log D3 base E plus the term is log D2 base E. And for these two terms, this one term and this term, we are having the common as J 0.866 I, and the remaining term is log D3 base E minus log D2 base E. And this one, observe clearly, this particular one is getting solved here, that is 0.5 log D3 base E plus log D2 base E, the plus term, that is of I into log D2 D3. Okay, this 0.5 I into log D2 D3, this term is getting to the power term. See here, mathematical analysis here, that is I log D2 D3 to the power of 0.5 into I, and I am writing here, this is the 0.5 is 1 by 2, 1 by 2 means the root, I am written it as I log root D2 D3 base E. Okay, I am considering this particular value here. Okay, and the remaining term is J 0.866 plus here the minus term, that means D3, it is, this term is getting as D3 by D2, this one is getting D3 by D2, D3 by D2. And for the further simplification, that see u0 by 2 pi 1 by 4 I plus I log, the term is here root of this term is minus term and taking the common as I, and this term is minus log r base e and log root d2 d3 base e. That means this minus term it is getting as root d2 d3 by r, root d2 d3 by r, plus the remaining term is j 0.866i log d3 d2 base e. And finally, we are getting the expression for the psi a nu naught I by 2 pi 1 by 4 plus log e root d2 d3 by r plus j 0.866 log d3 d2 base e. For the calculation of the inductance for this unsymmetrical spacing, that is La is equal to psi a by Ia. Psi a value is this one, I am substituting here by I. The I cancel and the remaining term is nu naught by 2 pi 1 by 4 plus log root d2 d3 by r base e plus j 0.866 log d3 d2 base e. Okay, and this is expression for the A, and we have to be considered for the further analysis by the consideration of nu naught value. Nu naught is equal to 4 pi 10 to the power of minus 7 by 2 pi. This pi cancel, 2 4 2 times cancel, 2 into 2 by 4, this one is 2 by 4, 2 by 4 means 1 by 2, that is 0.2. Here the 1 by 2 we are placing the same term 1 by 2, and the 2 into log root d2 d3 by r base e plus j 2 into this term we are getting the 1.732 log d3 d2 base e Henry per meter. This is for the inductance of the La, and similarly for the B and the C, the B term, see here the same one we are getting here, but the difference in the length value that will be altered. We will consider for the remembrance, see the continuation of this one, the sequence number of this one, see d3 d2 d3 d2 d3, what is the sequence? That is the d3 d1, okay, by r. And here what is the term here? d3 d3, then what is the next term? d3, that is d1, 1 2 3 3 after, then next one d1 by 2 d2, the next term is d3. And for similarly for the L3, 10 to the power of minus 7 1 by 2 2 log d, this is d3, for 3 after 1 again 1, the next term is 2, that is r plus j 1.732 log for 1 after 2 and 3 after 1 Henry per meter. And the inductance of each line conductor, the inductance of each line conductor is the La plus Lb plus Lc by 3, it will give the inductance of each line conductor. Here by the substitution of La, this particular one is the La, Lb and Lc, in this one the summation of this quantity by 3, we are getting this expression 1 by 2 plus 2 log base e 2 log root 3 cube root of d1 d2 d3 by r base e into 10 to the power of minus 7 Henry per meter. 1 by 2 is 0.5 plus 2 log cube root of d1 d2 d3 by r base e in 10 to the power of minus 7 Henry per meter. Here a conclusion point that if we compare the formula of inductance of an unsymmetrical spaced transposed line, with that of symmetrical spaced line, we find that inductance of each line conductor in the two cases will be the equal if this is the condition, if d is equal to cube root of d1 d2 d3, the two terms it is equal, d is equal to cube root of d1 d2 d3. The distance d is known as the equilateral spacing for unsymmetrical transposed line. And this is the calculation of the inductance of a three-phase overhead lines. I am simply concluding the topic that we are calculating the value of La, Lb, Lc for symmetrical spacing and unsymmetrical spacing. Thank you.